Hello everyone, thank you very much for joining this live event. We'll discuss today more about best practices with using functional programming with Java. If you're watching the event live, don't forget that we have a live chat there, so you can ask me questions in the live chat directly. If you're watching the event recorded, you can still ask questions in the comment section as usual, or you can find me on Twitter or LinkedIn and we can chat there as well. Why functional programming with Java? Why best practices? Why such a video? Because of course you maybe already know that starting with Java 8, Java got some characteristics that allows us now to work more functionally when we implement our capabilities, our app's capabilities. And since 7 years ago, because at the moment Java 8 has been released for about 7 years, if I correctly recall, we are able to use these features. So that's why they are most likely found in a lot of applications. And like anything else, at the very beginning has been abused. Developers didn't actually have some kind of principles to use those features like lambda functions, streams API, the optional class about which we'll discuss a bit today. As you might have heard me discussing in other videos as well, maintainability of an application is one of the most important assets of an app. So it's really important to take care about maintainability. Usually with maintainability we don't only care about our app being longer lived, so being able to maintain it and enhance it with new features throughout time, but maintainability, you'll be surprised, usually helps you also making more performant applications, and depending on the scale of the application, they are more robust, more scalable, and so on and so forth. And what happens is that when you use the language improperly, of course, the first point that gets affected by is maintainability of that application. And what I've seen is years ago, first of all, when I've started using Java 8, developers started, they were really eager to use these functionalities, these new capabilities of the language at that time, and they started replacing absolutely everything they could, like any kind of while loop, for loop, with streams, and they sometimes ended up with features that are instead of the purpose of the functional syntax they could use, which is making the apps easier to read, they actually got exactly the opposite. So they made the applications more difficult to read, more difficult to test, more difficult to maintain in general. So what we want to discuss today is not how to use these features, but how to properly use them. I will start by considering you already know the fundamentals about lambda functions, stream APIs, optional class, and in case you don't already know this, you can anytime watch some of the videos I have already recorded on this channel that explain you the fundamentals about the topics. But today we only focus on what's usually wrongly implemented with functional capabilities of the language, and how to properly use these language capabilities. Basically, what should you do, how should you change your programming style to make your applications easier to maintain in case you use functional topics. So first of all, I want you to understand that when you use specific capabilities of a given language, in our case Java, you need also to apply the proper methodology. So we know that Java is mainly object-oriented, so in general most of the way we think about our apps is in terms of object instances that collaborate one with the other to get to a specific result. And part of the implementation, so usually this is the big picture of an application, but we know that part of any kind of method we implement, we always also have some procedural way of thinking, because when you write a specific block of code of a method, you write that given block of code having a procedural thinking, which means you have instructions that you know that in a specific order, when you put them in a specific order, they will give you a given result. And whenever you hear that this definition of an algorithm, that you have some input, some instructions in a given order, and you have some result, that is a procedural way of thinking. But inside now our methods, we have also, starting with long time ago Java 8, we also have the possibility to apply not a procedural but a functional style. And what a functional style is, it's basically a more mathematical way of thinking in which the input is processed by a function and its output can be also the input of another function, which can have an output that's an input of another function. And that's what in mathematics we call the composition of functions. So it's something like in math you would say y equals j of f of h of x. And actually I have three functions here, which is the most nested one is h of x, and then the output of h of x is input of f of h of x, of f, basically the f function, and then the output of f function is the input for g, and at the very end we get the result. So that's how you compose functions in mathematics, and basically that's the way in which you have to think functionally whenever you use any functional language like Scala, for example, Haskell, or whenever you use any functional capabilities of a language which is at its roots not necessarily functional, like Java. Java is still object-oriented, but when you use its functional capabilities, then you need to change the way you are thinking to make it such in a way in which you think in terms of functions rather than in terms of instructions. And that in Java always applies in a block of code, in a method. When you write in a method, you have two options with Java. You either think procedurally or you think function-oriented. If you use the functional capabilities of Java, then you need to correctly apply the functional methodology. You need to correctly think in terms of functions. If you use a procedural approach, then you use it as you have used it by now as well, and you apply the procedural way of working. But be careful not to mix them, because mixing them will, even though it might not necessarily give you problems in terms of functionality, you might get a functional piece of code, that really does what you expect to, but which is more difficult to maintain, which lacks of maintainability. And the main reason we need to use correctly the functional approach when you get a functional approach is to be able to also keep our application maintainable, which again, as I said at the beginning of the video, it's very valuable. So let's see. I will take a lot of the points one by one, and I would like to discuss them with you. The first point, which I think maybe it's just my experience, but in my opinion is one of the most frequently encountered mistakes in using functions, is changing data outside of the function from the function itself. I don't think there's a new application I've been consulting on or working on where I haven't seen this anti-pattern used. And I will give you some example now so you know exactly what I'm referring to. And my, of course, recommendation would be to avoid doing that. And I will explain immediately why the philosophy, the functional philosophy, doesn't recommend you use it that way. So say you need to you have a list, just a simple list of numbers, integers. Let's call it list, and it's an arrays, call it off. I could have used also the list of interface method, since we have that also, but doesn't really matter, I guess. The idea is you have here some numbers, and sorry, as list. If I would like, I could have used list of or arrays as list. Anyway, and the idea of the exercise is very simple. I would like to get a second list where I only have the odd numbers. So how do I do that? Well, the anti-pattern is the following. So don't, let's say don't here. List result, so list of integer result is new array list, or whatever implementation of list you'd like to use. And then I go and I say list stream filter, which you know it usually it takes a predicate and it uses that predicate to filter for specific values. So in my case, I said I want the odd numbers, and then I say for each, and then I say for each number I get result add n. And this is an anti-pattern, so this is something you shouldn't do. And the reason is an anti-pattern is because from the function itself here, you are changing something outside of the function. You will find this in different flavors. I will give you some more examples. But the idea is the following. Remember what functional means. Functional means you have a function which gets an input, and then the output of that function might be the input of another function. That's fine. And then the output of that function can be the input of another function, and so on and so forth until you get to a result. But it's never in mathematics where you have some kind of a function you write that somehow changes data outside of it. So a function in math will always be a map between an input value and an output value. And the functional philosophy in programming, whatever the language is the same thing. You need to have an input and you need to have an output. And the function never changes something outside of it. So in my case, the input is this one. The first function I apply is filter. So this is in my case, say h of x. So I apply filter over the list so that I get in the end a different stream that contains only the odd numbers. And then I apply for each, and then I change something outside of the function. So I no longer have a result like I used to have when I apply for each, which is f over everything. Instead of giving me back the result, I try to somehow force the function change something outside of it. And usually this will always trigger problems in maintainability later on. So that's why you need to avoid that. And a better way to write it, so you should instead write it this way. List, I can't have two results, isn't it? So let me put it like this. List of integer result 2. In my case, I would like to keep both of them. And you say list stream, and you have to make it somehow in which the change will always be kept inside the function. So you will always keep your functional approach such that it's only a function taking an immutable parameter, and you get an output out of that function, which is the parameter of another function. The function never changes something outside. So in my case, after I apply the filter, a better solution, a better way, a better approach for my case would be simply to use the collect method that will give me the result. So you see, in this case, I do the same thing, but instead I never change from inside the function something that is outside the function like I did in my case. And this example is not the only one. So maybe actually let me say something like that: static void example1 here, and put all my code from the main to example1. You can basically then use main to call whatever of the examples I will give you here, and check that. In this case, basically check that the result is the same here and here. If you'd like to print the lists, you will see that they return the same thing. But again, you observe the big difference is in how I created the result in the first place by changing something outside the function. This is against the functional principles, while in the correct way of working, the functional way of working, if I chose to use the functional capabilities of the language, is providing the result without changing, only by using a function philosophy. So that's input, output, input, output, input, output, by applying function over function over function over function. So never by changing something that's outside. The same flavor you might see. Let me create an example too. So the same flavor might be, so the same problem with a different flavor, maybe it's better to say, might be, I've seen at some point one of my junior colleagues wanted to get a boolean out of a list, or something like, I don't know, let's say if the list contains any odd number, something like that. It's irrelevant, the result, but it's a boolean result they wanted to get out of it. So what they did is applying a stream, and then say filter, for example, and then say I get the odd numbers, and then I know for the odd number itself, when they get here with an odd number, they wanted to change a boolean value here. Say boolean b is false, and then of course the example in that case was more complicated because it was a real world app, but I tried to simplify it here to make it easier to understand, and they made it true. And then what they observed is that they basically can't do that. The language itself doesn't allow so the language itself doesn't allow you to do that, since when you use this inside of a lambda, well, the lambda itself is actually when it was built in Java 8, it was built over a nested type, so over a nested, in this case, interface. So it's basically a local type, with other words. In case you don't know how local types work, again, I won't now detail that. I'm going to allow you to go back and revise the lessons in the Java fundamental stream where I explain that. But one of the things you need to know is that Java doesn't allow you to change something in a local type. Like in this case here, prior to Java 8, you were basically forced to put that final in front of the variable. Starting with Java 8, that's what we call an implicit final. But the idea stays the same. So you can't. So Anchor must be final. No, it doesn't need to be final necessarily. Starting with Java 8 is implicitly final. Up to Java 7, it was indeed mandatory to make it final, but the idea stays the same. It's still final, so you can't change it. And guess what that colleague of mine found as a workaround is, say, I make this an object like atomic boolean, which, by the way, never use atomic boolean as a boolean, because that word atomic comes from its concurrency characteristics. So basically, this object is a synchronized type, and for specific methods that apply two or more, so several operations, it makes sure it synchronizes them. So it's related to Java threads, concurrency, that part of the language. So again, this is something that I discussed in an earlier video some long time ago in the Java fundamental stream. But the idea is don't use atomic boolean for something else, because it doesn't make sense. But what you will observe is that basically you can do something like this. So say false, say b set true, and yeah, it's working. But still, This is only a workaround. This is only a trick. It's not correct from the functional perspective, because it's still absolutely the same thing you did here with the list, which is changing something from inside the function. And wherever this applies, it doesn't matter if it's a for each, it doesn't matter if it's a boolean or if it's a list, it doesn't matter what you change from outside, the fact that you change it from inside the function is not correct. And maybe this is the most, again, frequently encountered anti-pattern you will get. So instead, of course, you have other ways, so you should do something else than that. So you can have a boolean, let's say this is b1. Okay, and then say boolean b2 directly. I would say is list stream, then I know filter, whatever what I wanted to do here was basically to check if I have an odd number, so I get the odds, and then you can say is, sorry for that, any match. Oh, sorry, directly any match here, my mistake. You can directly say any match in this case, and that's it. But anyway, again, this is a simplified example. I don't want you to focus on the algorithm itself or what we are doing. I want you to understand the anti-pattern, what you should avoid in, of course, real world scenarios. It will look differently. So allow me to read some questions now, and then I will go further with other anti-patterns. So almost 2 hours I was struggling with the stream, creating a list of consecutive elements and grouping them within a new list. Stream needs a lot of exercise. Through that, I do agree that Stream API has a lot of functions, and in order to grasp all those grouping by, partitioning by, methods that are some of them more simple, more complex, the collectors and so on, it takes a lot of exercise. By the way, I have some lessons, I think it's more than one, where in the Java fundamental stream you can see a lot of examples, and I think I took at least the most important ones that you need to know. So the videos you will find there hopefully might help you. Amazing idea, but it is a good code designed to define a variable and assign a value to it even if you are using it only once. That's probably a different subject. Of course, in my case, I'm only focusing now on the stream syntaxes, on the functional syntaxes. In my examples here, you can see my examples don't do almost anything. In a real world scenario, it depends if it makes sense or not to assign some value to a variable. Sometimes you assign that value to a variable only to name it somehow. You only to say that it has a specific purpose. Sometimes you decouple it just to have more instructions to make it easier to read. But again, that's another topic. It's not necessarily related to functional or non-functional. And of course, like many others, I do recommend you hear the Robert C. Martin's Clean Coding Bible, which goes through a lot of things from minor to major about how to write a code, your code cleaner. I would also say don't necessarily take every word by heart, because I also advise developers to be pragmatic. So don't necessarily try to take everything by the book. Not always, and not in always examples in real world that works. Is it possible to develop a Java program using only functional programming padding instead of PO? No, as I said when I started this stream. So when you use Java, you still think in object-oriented. And wherever you use a different paradigm is when you write methods. So because any method, from the big picture of an app, you will always have instances, objects, instances collaborating one with the other, and that's basically composing the algorithm, the way the data is processed in a Java app. And the Java will basically always remain at its roots object-oriented, and an app will always be starting from an object-oriented way of thinking. But when you write a Java app, you always here and there have to think procedurally, as well as maybe starting with Java 8 functionally. You are not forced to, of course, you are not forced to use a functional programming style, but you can, starting with Java 8. Java 8 and above offer you the capabilities you need for that. So when you write a method, for example, you have to take a decision whether you would like to write your algorithm in a procedural way of thinking. That is, you have instructions and you have an input, then you have operations in a specific order, and then at the end you have an output, and that's the procedural way of thinking. Or you might take the functional way of thinking, which is you have functions. Every function applies some operation on an input, gives out an input, which can become the input of another function, and they never change something outside of the function, which is a more mathematical way of thinking. So you will always combine, and when you use functional approach as well as a procedural approach, that will be inside of a method, which in terms of object-oriented, then from the big picture it represents what? The behavior of an object, because that's how you started learning most likely Java. You know that Java is all about objects which have attributes and behavior, and then the attributes are usually are defined with the fields of the class, and the behavior is the methods of that class. We cannot have a purely functional style in Java because we need at least to define a class, right? Exactly what I was saying, isn't it? So the big picture is always object-oriented. Procedural and functional is when you define things locally in a block of code, like a method. How can we exercise outside of work? Any exercise you can recommend? So what I actually do to exercise now, it's basically I will quickly answer this question because it's unrelated to the topic, and you can come back to me on Twitter or on LinkedIn further if you want to discuss more. I do usually read books which give me ideas to implement more stuff. I collaborate and contribute to open source where I can practice outside of work in different things, different frameworks that then help others as well. That's most basically what I'm usually doing, and sometimes follow tutorials, even though you'll be surprised. I like to record video tutorials and live events like this one, but I don't really like to watch them, as from the other side I prefer books. In my case, reading is what I always preferred over watching video tutorials. And then sometimes it looks better. For example, I had to return 6 lines long string from function. Return looks prettier if it's just one variable name. Cool, that's indeed it. And anyway, guys, because maybe I should have started with this from the very beginning, I don't want anyhow you to get that I want to say that the functional style is better than the procedural style. So mind that sometimes working functionally allows you to write less code and make your code readable. In other times it makes the code more difficult to read, and maybe you'd like to use a procedural approach in that case, which makes it easier to understand or separate in methods. Do you have any videos on reactive programming? Not yet, but I plan to make some. I like to read from sources like Java specifications. There are a lot of information. Cool, thank you, Dacian. That's true. I also like to read documentations now and then. Okay, and this was the first anti-pattern. So I think with this one you can keep in mind never, and it's against the functional style to change something from outside of the functions. Then another thing you should keep in mind is that, and I'm going back to something that I already said, never have linked chains. So whenever you solve a solution, and I will have to come with an example to make sure that I'm clear with this one. Whenever having any implementation, make sure that you only have one chain and don't create multiple chains. Imagine this example here where I had the list, and then my example was to take all the odd numbers and then just assume just with the odd numbers further I have to do something, it doesn't matter what. Again, in a real world scenario things would be more complicated, but imagine that I have to do something with the result here. So never ever do something like this. Never write list then something something something. Then there can be here a lot of intermediary operations, and then you have a collect, and then you start again stream, and then you do whatever you want again with, I don't know, with the stream. I will just put this as an example, but maybe it doesn't make a lot of sense for me here, but just as an idea. Any match, I don't know, and another condition. So never do something like this. This is chaining streams. So do stream, do something, a lot of things, then stream, do something, a lot of things, and then maybe even further, stream, whatever you have the syntax here. I've seen stuff like that. So wherever you feel the need to start a new stream for any reason, sometimes it can be even merged into the same stream. There are cases where that can't be done for reasons we don't need to discover now, but when you can't do that, at least separate the streams and don't allow something like this to happen where you have something very, very long and you start a stream from a stream from a stream from a stream. Whatever the reason is, you had to collect it into a list and then start another stream. At least start it separately. So you take this into a variable, and then from that one you start something else. And eventually, if I'm to go even further in the clean coding standards, I would even take them out in separate methods that would allow me to give them a name, like give the stream a name, tell through the name of the method what was the purpose, what I want to do. Take the odd numbers out of the list. That would be a good name. It doesn't have to be very long, but it has to be meaningful. When you read it, instead of reading something like this, reading a couple of methods names would definitely be more easier to understand when you have to change some kind of code that you've never seen in your life. When you use something, mind that Java offers you, starting with Java 8, not only the possibility of using streams and the optional and creating functions, but it offers you a lot of predefined functions. And in example 3, one of the anti-patterns I've seen in terms of functional programming is developers recreating their own functions when they would have already had one provided by the JDK. And yes, I'm here discussing about the Java util function package, where you have plenty of functions. I will name some of them here. So you've heard about predicate, you've heard about function, you've heard about by function, consumer, and so on and so forth. Supplier, by consumer, and many others. There are about 30 or 40 functions in the, maybe even more in the Java util package. Whenever you find yourself writing something like interface predicate, Boolean test of whatever you want here, maybe with or without generics, that's something not needed. So of course you can anytime write your own interfaces, functional interfaces, You can even annotate them with the functional interface annotation, which I will again be part of our best practices, but I will come to it later. But the idea is the following. In many cases, writing such an interface is not needed. Whenever you find yourself writing a functional interface, first of all, ask yourself if Java doesn't already provide one. And it's a best practice to use the already provided functional interface in the JDK rather than creating your custom one which does the same thing. So again, often thing I found. Now, let me see, I see more questions here. So more reactive programming mixed with functional programming, please. I think reactive, we will take the reactive approach later, because functional programming doesn't necessarily mean reactive. Of course, reactive usually implies using a functional approach, but let's take reactive in a separate video, which is related to a specific topic. And is it right to use stream just after JPA repository in terms of efficiency and clean code? I know what you mean. So if you take a list from the database with a query and then you use a stream to filter something, no, the answer is you should never do that. So whatever conditions you can put directly in the query itself and take already the needed details from the database without having to stream them afterwards is much better always than taking more data with less conditions and filtering them in the streams. Using it such a way, so using stream after any kind of repository is not good neither for performance, meaning both CPU and memory purposes, nor for maintainability. I hope that answers your question. Then, besides this third anti-pattern where we said always use the already existing functions, and mind that today it's very unlikely that you won't find a function to match your necessities in the JDK. So whenever you find yourself writing a functional interface, ask yourself if that's really needed. If you, however, at some point for some reason need to write a functional interface, then make sure you always annotate the functional interface this way, so that if someone later comes and tries to add a different method, one more abstract method to the interface, they are upfront advised that this interface you created was designed as its first purpose as being functional, which means it will or might have been used in lambda expressions, so that you shouldn't change it and make it non-functional, because then some other parts of the application that uses it won't work. And sometimes people ask me here, and so what? What if you, instead of using functional interface, what you just leave it without, and if someone really goes here and adds one more method, no, say it does that, won't this fail in those other parts and they will observe anyway? So why should I use the functional interface in that case? Well, because it's not always that compiling wise your code is linked to other code where it's used. Remember that a lot of applications are modular, or that you might be working and developing a library. When you do so, when you are implementing a library or a module, and you are not aware directly of who's consuming your library or module, then you need to make sure that you properly annotate any kind of interface that you want to consider for always being functional. Because once you did so, once you annotated this way, and that's the way your code says now, and this interface is meant to be used to be implemented as a lambda function, then you know that your 1,000 other applications out there using your library or module might have already started using that interface of yours as functional. So now if in the next version of your library you change it, then if you don't use the functional interface here, of course, nothing will happen. The code will compile for you, but it won't compile anymore for the other applications that uses your library or module. And that makes your code not backwards compatible, incompatible with code that already existed. And that's something you technically and architecturally want to avoid. So it's really important to use the functional interface for whatever from the very beginning you consider to be a functional interface, and you allow others to use it as a Lambda function. On the other hand, as a consumer of an interface, be very careful with using interfaces in Lambda functions if they are not annotated accordingly, because that doesn't guarantee you that specific interface will forever be functional. So if you use a library and that library exposes some kind of contracts through interfaces, and some of the interfaces have only one abstract method, then technically in Java you can make a Lambda out of it. Practically, if that's not that interface of that library is not specifically annotated with functional interface, you shouldn't. Or if you do that, because technically you can, you at least need to be aware that it might be in a future version of that library that you need to use, that the specific interface will not be functional anymore, because the developers of that library might have added more abstract methods to the same interface. And if they do so, then you will be the one who will have to change the code. So that's your awareness. You need to be aware of that. You do it on, it's your consideration if you want to accept that or not. And that's with the functional interface. Then what else we had? Exceptions, of course. So you even asked me about exceptions. One of the things about exceptions is that you might have checked exceptions. And let's see how this kind of code goes with checked exceptions. So say I have a method or an object I want to create, or I want to call. Example 4, of course, for that. And again, my list of values. And then I don't know what kind of method here that throws an exception. So if I have a method, again, a very simplified scenario here. I have a method throws exception. I don't know, it gets a value and returns the same value. I say list stream map x m of x, and do something then with for each, print them in the console. Then of course that doesn't basically work, isn't it? And the reason it doesn't work is because this method throws an exception, and in this case, then when you have something like this, I do recommend you avoid using methods that throw exceptions. Sometimes if it's your method, then of course you can change it, and you can use a try catch inside the method itself, but in some cases you can't change the method because it's simply a method from a library you use. So for example, I find this always with IO streams, you know, almost any kind of method from IO throws either a file not found exception or an IO exception, and with many examples in this case, with many examples, when I teach the IO streams, I have to deal with the exceptions. And what you can do in that case, where you can't do something like that, well, assume that method m is from somewhere else, then you can simply decorate it in your own method. I will just call it stupidly now decorate them, which of course in a real world scenario should be a different one. And then you can simply make sure here that you return your function, you catch whatever it needs to be catched, you treat it however you need to treat that, never leave a catch without a logic in it. That's contrary to whatever you'd like to do. Of course of X here, and then if needed you can even throw an exception, and I'm going to throw here runtime exception, but keep in mind that always custom exceptions are recommended. And then you decorate the M itself, so you say decorate M of X, and now you got nicely out of the exception, and you separated the way the exception is treated out of the stream itself. And I'm not sure if I actually heard about service provider design pattern, but I will make a note here because there are always things I can learn. So service provider. So maybe it's something that I know that I call differently, but since I don't know this terminology, I will have to research it. Sorry for not being able to answer you now. Yeah, and that's basically something you need to be careful with lambdas, because they are basically there are ways, there are cases in which you basically can't throw a specific exception and you want to throw it. Then a good approach is to separate the way the exception is treated in such kind of a decorator method that makes sure it correctly treats the exception of the other method. And again, imagine this is only a simple and stupid example where I have the methods in the same class, but it's only theoretical. But in a real world scenario, again, imagine here I decorated something that I can't really change myself to throw a checked exception. Then optional, of course. So let me also talk a bit about optional, because that's part of what we can use in a functional way, and that's also part of what I've seen many developers using it the wrong way. So example 5, and I think that's the last time I want to discuss about. So optional is the last part of the best practices for the functional programming with Java today. You know that starting with Java 8 you have this nice optional class, and this nice optional class has been implemented to help us avoid using null. And I won't stress again on how toxic using null is, because in many cases it's toxic, causing a lot of problems. One of my favorite problems caused by nulls in an application, in a class design using nulls, which was actually not really avoidable until Java 8, or not easily avoidable until Java 8, is the null syndrome. The null syndrome is basically, and you might have seen it as well if you have ever worked with such an application which is large enough and uses nulls, then sometimes you will see that developers actually start using if something not equals null, is something not equals null. Sometimes they even use that even where it's not needed. They are so afraid of the code returning a nulls that might lead to a null pointer exception, that developers start to actually add conditionals on everything for nulls. Not necessarily even where that's needed, just in case of, and that's called the null syndrome. And that's something that we need to avoid in apps, and optional is one of the ways we can avoid it. I won't go into a lot of details about optional because again it's not directly the point of our discussion, and I discussed optional in a separate video that you can still find on my channel. But what about optional? What I want to discuss now about optional is how do we actually use it, because we have two ways of using optional. We have the procedural way and we have the functional way. And in case of optional, I do always recommend the procedural way over the functional way. The functional way over the procedural way. So do use it with functionally rather than procedurally. You will observe that is shorter, easier to read, and when you get with the functional methods, a lot simpler. So that says, say I have an optional here of whatever you want. Okay, and then you have two possibilities. This is the procedural, where you say O is present O get, else something. And we have the functional approach, where you say, now depending on what you want to do with X in the end, you can say here O or else, and then you have either or else give me some other number, or you can have or else throw an exception, or you can have if present or else, and then you have consumer here and the runnable for the else. So this is the functional approach, and I always recommend the functional over the procedural for optional. So after a while you will find that using the functional approach makes the things a lot easier, shorter and easier to read, whatever the case is. I will end with one last code smell, telling you when you use a lambda function, never use braces, returns, and always, instead of a block of code in a lambda like this one, extract it in a method. So in this case, that's just an example where you can see the consumer and the runnable one after the other, which means what happens if an object exists, what happens if the object doesn't exist. In a real world, when I implement something like this, both this one and this one would get out as named functions telling me what exactly I want to achieve. So telling me, for example, do something with the number, do something if no number. And instead of giving them like this, then I do use, of course in this case, if I want to use them, they need to be static, but the idea is the same. I do use named functions instead of block of codes, and I do recommend you the same. Because in a real world, and even where it's possible, that will change in this operator, which is the method reference operator, will make things not only much shorter but more clear than seeing braces here and directly code. It's seeing the name of a method that tells you exactly what happens behind the scenes. So let's take a couple more questions and end this nice stream, which I hope you enjoyed. What do you think about the null object pattern? Where isn't it the same as optional here? So in case we have optional now, we most likely don't need to use a null object pattern anymore. Basically that would be something that you would have used prior to having to Java 8, which comes with optional. Some books you will recommend to a junior engineer Where there are plenty of books I would recommend for a junior engineer, in case of, I guess you refer to Java here, I do recommend the OCP study guide from Jane Boyarsky and Scott. I would like to recommend, of course, my Spring Start here, which is an excellent book for starting learning Spring. There are a couple of books on JPA and Hibernate I would recommend. Unit testing and the nice JUnit in action from Cătălin Tudose, that's something I would also recommend. And although Lambda is good in reducing coding and sometimes increase speed, I don't like it in Java but it's very interesting thing to learn. Yeah, anyway, different developers have different tastes, and as I've started this video with, and I will say it again just to make sure everybody heard, nobody forces you to use the functional approach. So the functional approach is an alternate way of implementing features to the procedural approach. Whenever you write a method, which is the behavior of an object, because Java again is object-oriented, so from the big picture you will always implement objects and make them interact one with the other to get the result. Any method which is the behavior of an object will somehow be written in a procedural manner. Or a functional way. If you want to do that, starting with Java 8, you have that possibility. So that's where you have to take the decision, what is best for me, what is best in our case. Is it the procedural way because we find it easier to read? Is it the functional way because we find it shorter and maybe more maintainable? But I will never say that one is better than the other, because in my perspective, like everything else in software, there's always a compromise there. So you will always make the right compromise for your implementation. Related to this, will you be covering more authorization server soon? Yes, I have. A lot of people ask me. I will cover that new authorization server soon. I just had a lot of things to do, and it was really difficult for me to to do more things. But it's there on my list, and it will be one of the next things I will cover. Why did Java not support catch functional method to catch exceptions in a functional mode? Catch exception in a functional mode. That's a good point. I'm not sure actually if that's really a functional way, because what I said is that a function takes an input and gets an output. So when you throw an exception, the question is that functional anymore? And I don't find an exception to map anywhere in what a function is in math, because remember, we started from there. The functional approach is an approach that starts from mathematics, from function composition. So when you wrote any kind of a functional equation, did you throw an exception? Never, because that's not something mathematically as a concept, or at least not something that I know as being. So most likely exceptions themselves don't really fit in the functional way of working. So that's why they don't implement that. Okay. Why can't we change the value in for each loop which is initialized before? I'm not sure if I understand, but anyway, I think I actually covered everything that I wanted to cover. Thank you very much for being so active. Thank you very much for being here, and I will close the stream now, but don't forget that you can ask me questions in the comment section as well. I will try to answer them. I do promise that I will cover microservices, the authorization server, everything else. I just try to find my time for that. And of course, don't forget to follow me on Twitter and LinkedIn, so we can get in touch there as well. And yeah, with that being said, thank you very much, everyone. Have an excellent time for learning further, and cheers.